Okay, in this video I'm going to look at the chapter 13 test from page 858. I'm just sort of doing some of the problems that are kind of tricky or I haven't really covered in a different video. So I'm not going to do a lot of these vector problems because it's either pretty straightforward or it's problems that are in one of the other videos, like the projection question, and then the same thing with the De Moivre's theorem question. I'm not doing number 26, which is very similar to the one we've already done in that video, where that one was x to the 6 equals 1. This one is x cubed equals 27i. I think you can figure out how to do that based on the other video. If you do have questions, you can let me know, and then I'll see if I need to make a video on that, but I think it's fairly straightforward on that one, based on the other video that you already have. The one I'm going to do in this one is 25, because that's kind of a tricky question. I don't think it's particularly difficult in terms of how to solve it, but it is a bit tricky because of a few things that could trip you up, and I want you to just make sure you're checking while you're solving a problem like this. Whoops. I gotta not do that. Luckily I didn't. I wasn't in the middle of solving a huge thing and I had to get rid of all of it. So let's look at 25. So 25 tells you 256 times 1 plus square root of 3i is your complex number z, and you're trying to find the fourth roots of it. So you want the fourth root. Well, all four fourth roots. The first thing we need to do is convert this into trig form. That way we can use De Moivre's theorem. To do trig form, I need to know the absolute value of z, and I need to know the angle. The thing we need to be careful about here is it kind of looks like the magnitude is 256, the absolute value is 256, because it's kind of written in that vector format where you have like a magnitude times a unit vector. That only works when this is a unit vector. This, unfortunately, is not given to you as a unit vector. This does not have an absolute value of 1. So that's one thing you need to be careful about. It's really tempting to just say that the absolute value is 256. Excuse me. So instead of multiplying this out, what I'm going to do is say it's going to be 256 times whatever the magnitude of 1 plus square root of 3i is. So the square root of 1 plus the square root of 3i's magnitude is 1 squared plus square root of 3 squared. So that's square root of 4, which is 2. And so the magnitude of z is 256 times 2, which is 512. So this is actually an absolute value of 512. The next thing we need to know is the angle it makes. Again, I'm going to ignore the 256 because that's just scaling it. Right, if I draw my triangle, this is root 3 and this is 1. I'm trying to find this absolute value. If I consider the 256, I'd just be multiplying 256 to each of these numbers, which when I divide them, the 256 will cancel out anyway, so I'm just ignoring them. This angle's tangent, so the angle is the inverse tangent of square root of 3 divided by 1. And using the unit circle, I know that's pi over 3. You stick to radians on problems like this. So usually when it's a pure math question like this one, where it's more of an abstract math, we're only dealing in math right now kind of question, you want to use radians. In this unit, you go back and forth between using degrees on some problems, radians on other problems. Most of the complex number stuff, that is going to be in radians. Your law of cosines, law of sines, when you talk about bearing, navigation, force vectors of different things, that's going to be in degrees most likely. So on this one, I'm going to keep it in radians. I have my absolute value, so I can write my complex number using trig form, which would be 256, not 256, sorry. I just did this whole thing on how it's not 256, it's 512. Let's take 512 times cosine of pi over 3 plus I sine pi over 3. And this is going to be the same as this number. You can kind of really just quickly check that in your head. The cosine of pi over 3 is 1/2. 1/2 times 512 is the same as 256 times 1. And this one is square root of 3 over 2 times 512 is 256 times the square root of 3. So this works out. So now the next thing we need to know is what the fourth root of this is. So we're doing the fourth root of z would be the fourth root of 512 times cosine pi over 3 plus 2 pi k divided by 4 plus I sine pi over 3 plus 2 pi k divided by 4. So now we're going to go through the k values and start writing that in. So for k equals 0, 1 second. So we know that I can kind of simplify this fourth root down a little bit. Not by much, because 512 isn't a perfect 4 power thing. But 256 is 4 to the fourth. So I can remove a 4 and keep the fourth root of 2 in there. Right, so this is kind of like simplifying radicals. I just took out something that I knew the fourth root of to just completely simplify this. So this would be 4 times the fourth root of 2 times cosine. K is 0, which would just be pi over 3 divided by 4. So pi over 12 plus I sine pi over 12. This isn't a unit circle angle, so I'm just going to leave it like this. K equals 1. So now I start off the same way, 4 times the fourth root of 2 times cosine of, now I put in k equals 1, so that's 2 pi plus pi over 3, which is the same as 6 pi over 3 plus pi is 7 pi over 3 divided by 4. So that's 7 pi over 12 plus I sine 7 pi over 12. And then k equals 2. Again, do the same thing. Cosine, now it's k equals 2, so 4 pi, which is over 3 is 12 pi over 3 plus pi, 13 pi over 3 divided by 4, 13 pi over 12 plus I sine 13 pi over 12. And then k equals 3 is 4, fourth root of 2 times cosine. Now I put in 3 in, so this is 6 pi, which is the same as 18 pi over 3 plus pi is 19 pi over 3 divided by 4 is 19 pi over 12 plus I sine 19 pi over 12. I don't know any of these cosines or sines. These are not unit circle angles. I could put it in my calculator and get them, but what use is that going to give me? I'm just going to have decimal approximations for all of this. This is an exact value. You want to give me exact values on your answers on problems like this. So this is your exact answer. You get 4 of them, so you start at k equals 0, and then you go up until you go through 4 iterations of this. So k equals 0, k equals 1, k equals 2, and k equals 3. You get your four roots. If you continued, if you did k equals 4, it would not be wrong, because you should be able to see that when you do k equals 4, you'll get back to k equals 0's answer. So that should be the signal for you to stop. Don't include it, because why would you include a double answer of something that you've already given me the answer for it? So don't include that if you go on there. But it's just sort of a fail-safe that if you do go more than required, it should kind of tell you to stop. Also, it's the fourth root, so there are going to be 4 answers. When you have 4 answers, you can stop.